Hi, today I'm going to show you how to read MiXCR reports generated by MiXCR analyze command. We're going to start by opening the terminal and we're going to go to the directory which we used in our previous videos. And here in the results folder, we see the output files generated by MiXCR analyze command for the Takara Bio full-length BCR preset. Now we see the output files for every step of the pipeline, and also we have report files for every step. There are two types of the reports that you can see here. The one is in JSON format and the other one is in TXT format. And JSON format is a little bit more extended, it has a little bit more information, but today we're going to focus on the TXT report as it has all the information we need to assess the quality of the analysis. And I'm going to start by opening the alignment report and walk you through the main records that this report has. Now here, one of the first important numbers we see is in the line number 7. I'm going to scroll down a little bit. And here in line number 7, we see the number of the input reads. This is the number of reads in the input FASTQ file. The next line tells us the number of successfully aligned reads, and we see that about 90% of reads have been successfully aligned to the reference, which is a fairly good number because everything above 90% is pretty good. Then the next few lines tell us due to what reasons some of the reads were not aligned. And here, for example, we see that 8.3% of reads were not aligned due to the absence of TCR or immunoglobulin sequences. And that might happen due to the various types of contamination. And one may export these not aligned reads and manually inspect them using BLAST or other methods to determine the origin of those reads. Then we have some minor issues with the absence of V hits and J hits. Those might happen due to some minor DNA contamination or other reasons, but the numbers are pretty low here, so we're not going to focus on that. Now the next number that I want to focus on is the number of the overlapped read that you can see in the line number 13. And here you see that more than 90% of reads overlap, and it is important to keep in mind the structure of the library and the length of the reads. Now here we work with the cDNA library, which was sequenced using 300 base pairs per den sequencing, which means that the reads should overlap. And that's what we see here. Now, sometimes if you see a high number of overlapped reads that should not be there, as for example, when you use a short sequencing reads like 150 base pair den sequencing, that might indicate that you have some non-target contamination in your cDNA library, which results in the short molecules. Now I'm going to scroll down a little bit and we see the next section starting from the line 25. And here we see how many reads were aligned to different chains. Now the next section from the line 31 to the line 39 is the trimming report. And that report tells us the number of nucleotides that has been trimmed at the end of the read due to the low sequencing quality. And here, for example, you see that for the R1 read, only 13% of reads have been trimmed on the right, and the average length of that trim is only 1 nucleotide long, which is pretty good. Now for the read 2, we see that almost 60% of reads have been trimmed, and the average length is 9 nucleotides, which is a fairly okay number, but still we should pay attention to that because sometimes due to the very low quality of the sequencing, the trimming might affect the huge portion of the read, which will prevent it from overlapping. And that is all that I wanted to show you from the alignment report. Now we're going to close it and I'm going to open the next one, which is the refinement report. That report tells us about the barcode correction and filtering. And here, I'm going to scroll down right away to the line number 8. We see that the input UMI diversity, which is the number of unique UMIs prior to the filtering and correction, is 61,000. And then the output diversity is 41,939. And the reasons for that we see in the line number 15 right here, which means that almost 16,000 UMIs had erroneous sequences and were corrected. And about 5% of the UMIs were filtered out due to the low quality. Now, the main thing about this report you can find in the section which is called filter report, starting from the line 22. And here we see that the initial number of UMIs prior filtering is 41,939 UMIs. And after filtering, we're left with 15,122 UMIs, which means that more than 60% of the UMIs have been filtered out. And that is a huge number, but in the next two lines we see that the number of reads that have been filtered out is less than 7%. Which means that all of that majority of the UMIs that have been filtered actually consisted from the low number of reads. And that means that the efficiency of the filtering was pretty high and we were able to preserve most of the data. And finally, we see the effective threshold right here. Means that only those UMIs that were covered by more than 6 reads passed the filter. Now that is all for that report, and I'm gonna close it right now. And finally, I'm gonna open the last report for the assemble. And here I'm also gonna scroll down to the line number 7, which is the final clonotype count. We see the final number of clonotypes, which is almost 9,000. And we see that here, about 78% of the total number of reads have been used in clonotypes. Then we see some reasons why the reads were dropped out. And I want to point your attention to the line number 10 right here, which says that some reads were dropped due to the lack of a clone sequence. Now, that means that 7.7% of alignments did not cover the assembling feature. And here that might have happened due to the extensive trimming because of the low quality of the nucleotides, but you should always keep in mind again the structure of your library and how the reads cover your library. Because sometimes if you set the assembling feature which is too long and not covered by the reads, you will see a very high number of reads drop due to the lack of clone sequence. Then we have the reasons for other reads that has been dropped. I'm gonna scroll that down here, starting from the line 26. We see how many clones have been assembled for every chain, for the heavy chain and for 2 types of the light chains. And then the last thing that I want to show you about this report is the pre-clone assembly report. Here we see the number of input groups, which is the number of UMIs, and it equals the number of the output UMIs in the previous report. And we're gonna go down here to the line number 38. And here we see that for 99% of the UMIs, only 1 clone has been assembled, which is something we would expect. Now I'm gonna skip the last part of the report as it's a little bit more advanced, but you can always go into the MiXCR.com portal, and right here in the docs report section you can find the description for every record in every report. And also keep in mind that these reports may vary depending on the preset, because different presets sometimes include different steps. And for every step, you will see a designated report, and you can always check with MiXCR.com portal to get the extensive information on every record on the report. Now, that is all for today. Thank you for watching.